So thank you for this interesting introduction. As a matter of fact, the level of my presentation won't be very technical on purpose. I will try to give you two perspectives. One is the expectation of big data from the business perspective. And I'd like to share with you some questions that I have on some of these expectations. The second part of my talk is more on what are the research and technological challenges that big data is posing. That could be interesting for students or researchers alike, but also there are a couple of questions I'd like to share with you. And then I will conclude with a personal twist, which is maybe looking at big data in another angle, which is typically not really spoken in normal conferences or at other situations. So the power of word is very important because, with words, you are raising expectation. So expectations are important. So if you see here, data is a new gold, or something like that. This is from the European Commission. They are strongly pushing what they call open data, so open the data for service in the public organization and public sector. But you see, the word is important because it raises expectation. So I'd like to review with you some of these expectations from a business perspective first, and maybe looking a little bit inside of what the meaning of this expectation. So first of all, what is big data? Big data is around it's always been around, but now what is very interesting is that data is not only the typical structured data that you store in typical relational databases as we know about it, but it comes in different kind of format or no format at all. Like, for example, video, digital pictures, intelligence sensors, GPS signal, and so on. Now, all of this kind of data in volume, but especially in structure, does not really fit into conventional database systems, because they are different kind of things, and there's a lot of them. So, having said that, when we talk about big data, typically, we need to distinguish between three categories: big data, open data, linked data. Now, in general, big data, if you want to have a very rough definition, is anything that doesn't really fit into an existing database because it's too big, it's too fast, or the format is too complicated. And that's actually what I will cover in this talk. There are a couple of other aspects of data that are typically looked at, especially in Europe. One is called open data. That refers to a subset of data that you want to make it freely available for society. For example, for commercial, non-commercial purposes. Public governments are such a case. Now, they have a lot of documents, most of them on paper, and then they digitalize it, and then opening up is a political act. Because that means you have access to information, and then you can build your services on top of that, and it's another way of reaching out the citizen. The third one is called linked data, and it's actually linked to the semantic web, which basically means that you would like to link the data together in an intelligent way in order to have a kind of network of data. The interesting thing is the free communities, they develop their own tools, they have their own jargon, but they hardly talk to each other. Interesting. The vendors of big data are not necessarily the vendors of open data and linking data. The scientists are actually working kind of in parallel, but there is a kind of different angle. And to some extent, it's all about data. But, I will focus more on the first, on big data. So, there's a definition that I've taken from one of the first reports that was written by McKinsey about big data. A couple of years ago, one of the first, that said big data in everything refers to data sets whose size is beyond the ability of typical database system to actually capture it, store, and handle it. That's kind of neat because, in other words, data will grow and technology kind of follow. And if you start talking about petabytes, then you are on the big data side. And anything below that, is large amount of data, but whether it's actually fitting this definition is not the case. I mean, typical relational database system can still handle terabytes, but when you talk about petabytes, then you are really in trouble. So, the European Commission has decided recently, actually in July, that digital economy and big data is an important topic. I think he's reacting somehow to some of the situation in the market, and they issue a strategy where, and it's called the data-driven economy, which is basically a document that they published recently in July 2014 to promote a data-driven economy in Europe. That's an important statement, because then the European Commission is actually driving somehow the politics in Europe. And Europe is actually several countries, there's not only one. And they realize that data is an important asset. And you need the tools, you need the skills, you need the funding. So as an important priority is a statement, it is an important statement the European Commission has done, quite late if you think about it, but at least, better late than nothing. So, and I'd like to give you an idea of some of the expectation. This is taken from their document. There's a lot of expectation. There's an expectation that the market will grow considerably, much faster than typically, that a lot of new jobs will be created, and that's very interesting, the European Commission is kind of scared that we are lag behind the United States. So what they're trying to do, they're trying to figure it out, niche markets where they think big data might have an impact. And these niche markets are not the usual digital marketing, are not the usual fraud detection, are not the typical suspect use cases, but they're more in vertical, like food security, intelligent transportation, healthcare, energy, and stuff like that. If you think about it, that there is a trend of intelligent sensors, like intelligent meters coming up, this is actually a challenge for everybody. So big, actually, vertical markets. It's going to be a new industrial revolution. Well, this is actually something to be discussed. I'd like to share with you this slide, which is taken from the European Commission, just to give you a feeling that we Europeans kind of feel that we're late, especially in the development of technology. Well, there are many reasons why the Europeans are lagging behind. First of all, there's innovation, in software tends to happen here more than sometimes in Europe. But in particular, when you talk about data, and data is something that is not software, it has a meaning, it's connected to people, for example. In Europe, there's a lot of rules and regulation, and also attitude towards privacy of data. For example, I'm located in Germany, and they're very sensitive about data ownership and protection, to an extent that each country has its own attitude and its own rule and regulation, and each of them has to be kind of taken into account. So there is no one single Europe, although data is all over the place. And data is beyond Europe, is worldwide connected. So, and you need the legal environment, you need to figure out different kinds of problems that are not only technical. Because, when you start basing your decision on data, then it has an impact on society. And there are a couple of issues that are important, and these are actually mentioned here. And of course, it's also a matter of investing money in educating people, building new tools, and stuff like that. So what is the answer of the European community will be, you'll see, a new program. But the important thing is, what you want to do with big data. It's important how people use words. Now, I'm taking this exactly as is written in this official document. It's an official document. They say, in general, analyzing data means better results, processes, and decisions. Now, let's start critically looking at this statement first. I'm taking the statement in pieces, and then we can start talking. Now, in general, analyzing data means better results, processing, decision. It all depends on the intention. So, depends on your intention. So, if your intention is good, then this is going to happen. If your intention is different, is not necessarily that in general this will lead to something better. No, I will talk later, for example, one of the promise of data analytics is better transparency. But better transparency is not necessarily always something that people want. You see, this is I'll give you an example later on. So, and in the document is written, as technological advances, entire business sectors are being reshaped by systematically building on data analytics. It's a very strong statement that I would rephrase rather than the business with society. So are we ready to have a society being reshaped by systematically building on data analytics? It's important to look at each word, because this is a word that I didn't write. This is an official word of a body which has a kind of political power. It would be like the White House that writes a document, and it has an impact on people, on research, on young people, on vendors, and things like that. So I'd like to share with you that sometimes the expectation have to be really looked carefully. So what is big data supposed to create? Value. Now, and this is the example I want to make. And this is taken from one of the first McKinsey reports. You can read the list of the supposed value, one of which is creating transparencies. Now, let me tell you a story. I was involved, I saw a project of a large car manufacturer. I don't give you the name, I don't give you the country, so you have no idea. It's very large. He has cars and trucks all over the world. Somebody in marketing decided that big data should be really important for the company, and they decided to start a big data lab with the intention to create a better production, reducing cost and stuff like that. One of which was to reduce the cost of maintenance of trucks. The company was selling trucks all over the world, and then with predictive analytics that they will look around patterns, they discovered that an area in the world that I don't want to disclose has a strange pattern. They were having higher cost. Now, if you think about it, somebody in the company was not very pleased. The country manager of that area wasn't very pleased. Because when you start digging into the data, you actually end up discovering things that maybe people don't want to share. I'll let you just think about it, what could be the implication. So it's a very political act. It's not only technology. And the second part of my talk is more about technology, but we need to be prepared to understand that all of these nice things that are written here sometimes means something that goes beyond that. Of course, segmenting customer means, you can probably target your customer better and stuff like that. But other things, you really have to look at carefully. So I think the real value is combining the data together. What it means, I think 90% of data is already in the hands of a corporation. And then you have maybe 10% of social media around, and now it's coming up this trend of the so-called Internet of Things, where sensor data start kind of producing data. For example, smart meters. Now, PG&E just installed smart meters in the house I live in at the moment in San Francisco. It collects data and it sends data somewhere. So this data is now there. Now, if you are a bank, you probably know all about your customer because you have your database. But now, all of a sudden, you have other information around, maybe in social media, maybe in some other GPS, whatever. And it's important that if a company can combine all this information together to extract something, they might create some value, which is a challenge also technically. So I think that's really combining data together. Then when you combine the data, you have to explore the data. You need to figure out what you're looking for, which is not obvious. And once you did some analytics or some kind of modeling, you need to be able to visualize it. Otherwise, nobody understands what you have. And that's a kind of search. Let's call it big. Sometimes people call it big data search. Combine the data exploration, analytics, visualization, and here we go. Then you get something that you need to be able to understand. These are some of the typical examples of big data use cases. They're very different because, log analytics, everybody knows. Fraud detection is a very popular one. I mentioned two, the last two, which I never mention normally. That's interesting. Now, if you look at all kinds of reports, the McKinsey report has the first 2, 4, 5, but the last two I added myself. Now, obviously, data is also used in politics, also used in security, but people tend not to even talk about it. On talk about the challenges of this use case are very different. You will see that when we talk about the velocity of data, so how fast you need to react to data coming, you can go from milliseconds to seconds. So the use cases are very different. Digital marketing is quite good in seconds. Fraud detection, sometimes you have to do in milliseconds. So that's the kind of different challenges over there. The sector that normally are looked at as promising, at least from McKinsey perspective, this one here, but there are more. The public sector administration has an intrinsic problem because there is not really an incentive for them to open up their data. There's not a business incentive for them, so it has to be a political will. In the other case, of course, healthcare is a major issue, retail, everybody knows, manufacturing, and all these other verticals that I mentioned before are extremely promising. So what are the consequences? Well, this is taken again from the European Commission. First of all, the underlying technical infrastructure doesn't work very well, so you need to kind of change it. And that's why it's a great opportunity for researchers and vendors alike, because all of a sudden, new challenges and new possibility to develop different tools, different databases, different platform, different things. And that means that you need people with skills. And typically, you need trusted environments, for example, and the skill of the people. You cannot have a database guy here and a guy who knows analytics here and a business domain here, because they need to work together. And my experience is that typically when they work together in a multidisciplinary team, it's very difficult even to understand the terminology, because somebody's a database guy who knows about the core database, talking to somebody who's an expert in analytics, they might not even understand each other. And then you need the business guy who knows about the use case. So, and this is actually important because training of professional is very important. That's why for university also is an opportunity, but also is a challenge because not everybody has all of these skills. And some of the tools are really complicated. So the European Commission has come up with this kind of definition of data-driven innovation, DDI, and I think it's interesting because they look at both the business and the public sector. That's a very European attitude, which I think is good because, there's a business, there's a public sector, and I would say the society at large. I think that's an important thing. They launched a new funding program called Horizon 2020, which is basically the next generation of funding for applied research in Europe. And as you can see, one of the major focuses is on data. So this is like I think it's some kind of reaction also to what is happening here in the United States and in other parts of the world. Now, some of the limitation that has been mentioned when you do a project with big data is that you really have very few people who have the skill to run such a project. So, because you need knowledge in statistics, machine learning, database, distributed system, and somebody who understands the use case. Because, it would be totally useless if somebody has a great technology, but then they invent a use case, which is one of the very important facts here. And also a challenge for the data scientist as a profession. Now, McKinsey mentioned some issues that are mentioned as follows. Data policy, which is more on the technological part, and I will devote the second part of my talk. And then issues that are less technological, privacy, security, intellectual property, liability, access to data, because, integrating the data and the different in industry structure. As I mentioned, the public sector has absolutely no incentive to open their data. In some other sector, the incentive is more business-oriented. So, just to finish this part, again, the European Commission has highlighted a couple of areas of interest, and I want to mention two. Internet of Things is a quite interesting one because, it basically means sensors data. So sensors that start generating data, or the intelligent meter, the smart meter is one, but you can have many more. The interesting thing is when you look at sensor data, there's a lot of noise. So in order to get the signal, you need to kind of filter all this noise and get the value. You can think the same with data, not only sensor. The entire big data has a lot of noise. And in order to extract some value, you need to filter out that. The signal reminds me a lot of digital processing of signals. In fact, there are some researchers you see in San Diego that have a background in electrical engineering and are applying technique in digital processing for signals to big data, because somehow it's quite similar in some way. Cloud computing is playing another role, but it requires some infrastructure, and especially it requires that the user are willing to use it. So, as any technology, okay, that's a quote I found. That's interesting. I was going in a garage sale here in San Francisco, and I found a book, a college book of media. And I found this quote that said, any technological or social force that reaches down to affect the majority of society members is bound to produce a number of controversial topics. This guy is called John Bittner. I'm sure you don't know him. 1977. So he was talking about TV, talking about a few other things. But if you think about it, and that's the question I'm asking now, what are the true consequences of a society being reshaped by systematically building on data analytics? That concludes my fast overview of the business expectation. Now I go more into an area where it's close to my field, which is, the technological part, the big data research challenges. I divided in three parts, the data part, the process, and the management. And I go through this list. So if you look at the data challenges, you have certain elements that are common. The volume. So since, how to deal with the size of this big data. It has to be petabytes. When you have any application that needs petabytes of data, then you are somehow in trouble because existing, the conventional relational database systems don't scale. Now the question to ask is, who has a need of petabytes of data, really? Of course, Facebook does, Twitter does, but if you're a bank, it's unlikely that you have petabytes of data, unless the bank becomes to expand in the social media, or unless the car manufacturers start tracking down all the visits of people on their website. You see, it's all about what kind of data you want. So, I think the volume to some extent is not even the hardest challenge. You'll see, I think the variety is the most important one, because handling multiplicity of types, sources, and formats. This is really where the technology that we used to have falls short. Structured data, everybody knows, I have my form, I fill the form, I put it into a relational database in nice table, and here you go. I can query, I can update, beautiful. But let's start talking about raw data, semi-structured data, unstructured data, like logs or census data, or pictures and video. Then all of a sudden, it gets complicated because the technology was not meant for that. Of course, you can try to extend it, but combining with the volume, then you start having a problem. That's why you have all these innovative vendors and researchers that are trying to come up with different kinds of technology. Some example of variety. So these are examples of semi-structured web data, A/B testing, seasonalization, bot detection, pathing analysis, require analytics at scale on petabytes. And graph are also an important thing. Sensor data is important. I think I would like you to pay attention to sensor data because it will very likely become an important factor. And the issue there is separating signal to noise, because you don't really need all this data. Think about it, a smart meter. Now, you have a smart meter. I don't know who has a smart meter at home, but I got one installed. Now, think about it. Where is it going, this data, and for what? Maybe they can tell you, look, you've been taking the shower recently too often. Or the temperature in your house in the last 24 hours was actually above the average, or whatever. And and then you also receive a lot of information you don't need, because you don't need this data every millisecond. So then you have lots of data, and it's accumulating. Then a few other challenges that are actually important. The data availability. Is there data available? Now, this seems to be like an easy question, but it's not, because if you're using data for predictive analytics and your data is not available or is partially available, whatever you're doing will not produce the results you want. And the data availability might have all kinds of limitations that are not technical. For example, you can't have this data because it's sensitive data, or because you have no ownership, or because for all kinds of other reasons. And once you have the data, who is telling you that this data has a good quality? So determining the quality of data sets and their relevance to a particular issue is not a trivial case. And think about it, a good process will typically make bad decisions if based upon bad data. So, and that, this is no more a database issue. This is becoming a data issue. Who is able to decide if the data set is good for what you want to do? If you're in healthcare, you start worrying, if the data set is not good. So, this is an example mentioned there. I think it's very important, but also is a challenge. It's an interesting opportunity for people that have something to contribute on that part. Another important and often mentioned challenge is velocity. Reacting to the flood of information in some kind of real time. Now the data comes, and then you need to react. Of course, not every application has to react in the same way. You can react batch, so I store it, and I process it batch. Or I need to react on the fly, but it's different if you need to react once in every second or every millisecond or whatever. The velocity is a challenge also for conventional technology. And again, if you have sensor data, then you can stop them. It goes. Veracity is an important, often not really thought challenge, because how can we cope with uncertainty, imprecision, missing values, misstatements, and untruth? Again, it goes to data quality, because at the end, if the data is not good or true, then you have a problem. And also another big challenge is data discovery. How to find the data. Maybe the good data is there, but where? Especially if it's web data, it's quite important. And at the end of the day, once you're finally able to collect all of this data, now you're not finished, you just start, because you need to combine these multiple data sets from all different places in order to start doing some kind of analytics. But think about it, sometimes you don't even know the source, or didn't even know. In this particular example of the big data lab in this car manufacturing, they were exporting data from Oracle database without even knowing the schema, and they didn't even know what was the meaning. How can you do analytics if you don't even know the meaning of the data? So, and that's some very practical challenges. That's why it's needed a few solutions. The data comprehensiveness, we discuss it because, it might be the certain area that are not really covered, and what are the implications? And this is a big is a big topic because most of the time data is linked to people. And this data can identify directly or in an indirect way people identity. Now, of course, you could say, well, it's all about attitude. If I leave all kinds of traces on the internet, I have a Facebook account or I have a Google Plus account, and I leave traces anyway, so maybe there's a need of changing something. But you have to understand, this is exactly the quote of 1977. Very sensitive area. Just an example, in Europe, where somehow people tend to be more sensitive somehow, there's been a kind of legal case called the right to be forgotten. I don't know if you heard about it, but there was somebody with a lot of money that did something not particularly nice, and he went on the internet all over the place, and he wasn't happy, and he went up to court and won the possibility that Google will remove all the links where he's mentioned in a certain episode. This is the right to be forgotten. Google is receiving 1,000 requests a day to remove search links, totaling under 45,000 requests only in Europe for something like 500,000 web links. The funny and paradox thing is that this only works in Europe, which is kind of totally bizarre because data is all over the place. If I'm in Asia, then I can still see it. So I wanted to say that this is really an emotional and very important issue that is kind of outside our control sometimes. Another important, and I think an important, yes?
It's also sort of goofy because Google doesn't have the data. Why not, if it's a link to a European newspaper that actually has the story that the person's objecting to being found?
Yes.
You've broken the wrong part. Killing Google's link doesn't make the data inaccessible. They're not forgotten. They're just Googleable.
Very much correct. But you have to.
Google still has the data.
Sure. But you have to also consider that the person that are afraid of being visible, they're not necessarily technologists. They don't want to be seen in Google results.
But I can see the person.
Of course, there's a history of the data, but these people are so afraid and they go to court. The interesting thing is now that what has happened that Google, as far as I understand, has created a kind of internal board to decide case by case, these 1,000 cases, which one they will delete the links and which one will not. Which doesn't seem to be actually the solution to me, because it cannot be the company deciding which link to delete and which are not. At the same time, if you leave the decision to the outside body, then somebody's controlling the decision. So it's not an easy issue. And you're perfectly right. It's not even a rational issue, because it's like somebody did something that is ashamed of, and all of a sudden there are traces all over the place. Now, in the first place, this is a personal problem of the guy or whatever left traces. And if you're ashamed of what you've done, that's a consequence of having data all over the place.
Well, but it'll disappear out of Google if we take it out of the London Times.
Yes.
In a short period of time. Whereas if you take it out of Google, it's still on the Times website.
Right, but somebody went to court to make sure that Google would be then removing the links. I'm only telling you the facts.
Which is also known as a market opportunity for a search engine outside of Europe.
Maybe. I didn't think about it in this way, but...
You're at Stanford. We always think about that.
Okay.
And how are these competitors doing currently? Not so good, particularly in Europe.
But I think the whole issue wasn't really a business issue. It was really a personal issue. The situation started with somebody who was a very high-profile image, and then all of a sudden something happened, and then this was in the net. And then it became shared to everybody that can simply Google the name of the guy. And this guy freaked out. And since he has a lot of money and a lot of patience, he went through all the steps. And it doesn't matter. As you can understand, it has nothing to do with logic. It has to do with some kind of irrational emotion. But it's, again, the consequence of data being shared. So that's what I think is very much connected to what I mentioned before. I only mentioned that. Data documentation is very important as well. We should always remember that people have a very important role. Not that we think, predictive analytics will be the only way, especially in healthcare. Think about it, You don't want a completely optimized system that will predict something for you. I think the role of domain expert has to still be important. This is an interesting quote. It would be worrying if the healthcare sector only responded for flu outbreaks when Google Flu Trends told them. Very actual now with some kind of situation with the Ebola and stuff like that. Now, on the process, we have a few challenges. How to capture the data? Not easy. So that's why there's an opportunity. Once you have the data, how you align it from different sources? That means resolving conflict, resolving different semantic. In order to have the data, you can transform for a suitable form for analytics. So there's a process. It's not obvious, especially if the data is spread around in different parts. The model, how to model it, and then how to understand the output. That's very important, because if you've done all the work and you can't really present it and somebody cannot really understand it, is that no issue? Visualization and sharing the results is also an opportunity. These are some of the management challenges. Data privacy, we talk about it, security and governance. Now, this is not new. I mean, if you think about it, even data warehouses had already this concern. Legal and ethical concern always been existing. Only the difference is now that before, in data warehouses, you wouldn't really have the data of every citizen. Now, with big data, it's much broader. You reach more people. And it goes more down into society, and then people react. Before, it was like only for technological people, BI. Now, all of a sudden, everybody has a profile, and then you start hearing the consequences. Somebody has a profile in Facebook, and then the people that are hiring somebody are checking their profile. If you don't have a profile, they think you're not social, but if you have something in the profile that is not good, then they think it is not good. So, and these are some of the challenges you have, and also security is an important thing. In terms of analytics, and it's an interesting paradigm shift now. The application logic should go close to the data and not the other way around. I mean, normally in the old kind of database stack or database way of thinking, it was the other way around. But now with this mass of data, it should be the other way around, which also poses a challenge on the technology. So until you're talking about terabytes, current database systems are quite okay. But when you go to petabytes, then all the classical relational database system doesn't really scale. This is actually not something new. It was actually already discovered by people working with astronomy, for example, where you have a massive amount of data and you need to put the analysis close to the data, not the other way around. You don't send the data to the logic. Here is an interesting observation. So I was talking about astronomy. If you think about it, people that work in astronomy, and there is a guy called Alex Salai who worked also with database people a long time ago. They make an observation that astronomy is becoming a data-rich science, and this was written in 2004. Please notice the quote. Data is everywhere, never be at a single location, not scalable, not maintainable. Is talking about astronomy data. But if you think about it, not scalable, to some extent not maintainable because you can't really handle it. Data is everywhere. Interesting, never be at a single location. This comes because there's evidence that the universe is expanding. Big Bang, and the universe is expanding. The interesting thing is, I learned that there is no center. So if you have any point in the universe, you will be seeing the universe expanding, but you take any different point, it's expanding the same way. So there is no center. And this is kind of somehow the same kind of experience that we have when the data is overflowing us. The only difference that astronomy, I think, for many years was not a business case. Now data is becoming connected to a business interest, and then some of the experience that the astronomy people have done are kind of different. Of course, the format of the data is different, but some of the challenges are the same. Also, an interesting quote. I was actually privileged to interview a few interesting people in the last years, and I interviewed the CTO of Amazon a couple of years ago. And interesting quote is especially this one that says that when you query in the old days, you know exactly what you're querying. You know exactly what you want to ask. In this new world of analytics, you kind of don't know exactly, so you're exploratory. So you need all kinds of different ways of doing analytics, which is different than the usual one in business intelligence, for example. Evolving over time. Of course, he's pushing, his cloud. So the second part of the quote, not constrained by resources, of course, they're pushing their own cloud. But the first part of the quote is very important because it's also a paradigm shift in the way analytics are done. So that's why big data analytics is not the same as the conventional business intelligence. That's why, because the way the data is there is different, and then you need to figure it out without really knowing what you're asking and figure it out what kind of patterns you find. Now, the interesting thing is that if you want to analyze, you need to find the right model. That might take some time because you might not get it right in the first place. And it should be at scale, large amount of data. So that's one challenge, how to do analytics at scale. And second, how to do in real time. Now, in real time means that somehow you don't want to live in a batch and then do something and give you the result maybe the day after. You want to do it on the fly. Also here, real time, what does it mean? You can have digital advertisement like Yahoo does. A second would be fine to do React. Some people in fraud detection want to have it in a millisecond. So that's the difference. So the requirements are different. And then if you have disaster recovery, it might be really important to be really hard real time. So it's all about the intention and the requirements. But obviously, when you have real-time analytics, large amount of data with velocity and variety, that gets really complicated. And it really gets into a situation which is different. Now, my colleague in database decided in October 2013 in a kind of self-assessment report to the database. Big data was an important research topic. Since I'm also part of the database community, I think we're a bit late, but nevertheless, and here we are. We have a list of very important people that really are shaping the database world and some of the distributed system world people. And these are some of the challenges that they found. I found quite interesting that 1, 2, 3, 4 are with recovery. The fifth one is interesting because I realize that people have a role in this process. And that's important. So we're not really ready even managing diverse role of people in this data life cycle. There's a report that one can download. Why existing database systems are not working? Because when you have a system that was built for structured data and with certain kind of volume in mind, and when you have a volume that gets higher, this system don't scale. Then operation like a join that will work quite fine in certain amount of data, then when the data gets higher in volume, won't scale anymore. And parallel database systems do have a problem exactly because they were not really meant to scale up to a certain level. So that's actually one of the challenges. That's why you have so many vendors that are coming up with new different technology, because they started to create new kind of storage system rather than retrofit existing technology. Scalability has three aspects. The data volume, we discussed it. The hardware size, meaning it's your choice. Should I have lots of commodity hardware or big servers? But there's a limit even to, it's called scaling out or scaling vertical or horizontal. Horizontal means you have a lot of commodity hardware and you try to distribute your work so that it works. If it's vertical, then you have powerful, expensive machines, but you reach a limit. That's the point. You can add big machine, but then you reach a limit. And concurrency, because ultimately, at a certain point, some of the properties, like transactional property, you cannot really have it anymore. And there was a big debate, and an interesting question. Would you have your bank account being handled by a NoSQL database which has no ACID properties? So the question seems like, wow, everybody has done a course in database one, and then you know that ACID property is very important, and then you need strong consistency. But then if you think about it, how banks work, your bank account is never perfectly consistently updated on the spot, because it's a policy. It's not about the database, it's about the people, it's about the internal policy. So I was kind of surprised when this discussion showed that at the end, yes, you can have a system that has ACID transaction properties, but if the decision to update your bank account is taken by a manager a day after, your bank account is not consistent. It's eventually consistent. Of course, people can still say, well, I prefer to have a strong consistency, but these are some of the issues. When you have, for example, friends in Facebook, and you have an eventual consistency, that means that maybe at a certain point in time, some of your friends are not there because they're not being updated. Okay, so what? Maybe one hour later, you will have them. So it also depends on the kind of application. I think with banking, since it has to do with money, you might be more sensitive, even if eventually your bank account will be consistent. I think an important aspect is that there are so many tools now to try to move data from all kinds of different data sites, data stores. The ETL was already a difficult task in conventional business world. Now it become even more complicated. And there's a need of some tools for integrating and moving data. So here is a debate. It was actually quite well described by Mike Carey, as a database scientist, in a keynote in 2012, and actually said, well, big data in the database world, early 80, was parallel databases. Well, sure enough, in architecture, and then and if you think about it, for many years there was not an open source parallel database. And then in the 90s, non-database people, system people that are expert in distributed system, revolutionized the whole thing. Then you have the Google Big Table, the Amazon Dynamo, and eventually Apache Hadoop and all kinds of other MapReduce. And this is not a database contribution. Of course, it has an impact. The database vendor, the classical, re-implemented some relational database. Here are some names, you have it in there. So, what is the situation nowadays? If you want to analyze big data, you have typically, as a state-of-the-art, either a parallel database or NoSQL or in-memory databases. You might have a Hadoop connector. You still have the data warehouses. They're not going to go away. So now all of a sudden the question is, but what is the platform for big data? So you have NoSQL, you have, for example, document store, key value store, they are column-based, so as opposed to relational. You have new SQL, so implementation of SQL for analytics. You have in-memory databases, where most of the data stays in memory. And of course, this is due to the improvement of the hardware. Before it wasn't even thinkable. You have the Hadoop. You have the data warehouse plus scripts, workflow, ETL-like data transformation, so forth and so forth. Here is an interesting situation now. If you look at many vendors that are trying to define an analytical big data platform, they have this kind of variation of that. The question is, and that's the question for database people, are we going back to what we call in the early days federated databases? Federated databases never really work. But here you have all kinds of data all over the place. But the intuition, I think, is that there are so many moving parts. And if you start moving data, for example, I have data in Hadoop, and I pull the data to do analytics and pull it back. It might work if you query, but if you start updating, you start changing something, then you start having inconsistency. And on top of that, when you move data from one place to another, it costs a lot of trouble. So this is the situation that we have at the moment, which is also a challenge because many vendors are working on solution on that. And there is not one solution to that. Interesting thing, and since we're in research, you can build your own database. Google can, so they build this Spanner, which is a scalable, multi-version, globally distributed and synchronous replicated database. Interesting enough, Google replaced a sharded MySQL for the AdWords. Now, this is a very crucial business for them. It's a 24/7 business, so AdWords. And before they have a sharded MySQL, didn't scale anymore, and they implemented themselves another database called F1. Interesting, because Google was the one that implemented the big table, so they kind of started an NoSQL movement. Now all of a sudden they have a database on top of Spanner, which is scalable, at least they claim so, and is SQL. So the question is whether SQL is coming back. I'll tell you in a minute. If you look at Hadoop, which is the other component, which is many more components than simply Hadoop, at the end is typically batch-oriented. There's work in trying to improve it for real-time analytics, but still, when you have Hadoop, you don't really do real-time analytics. So that's why you need these other tools that are doing real-time analytics. A couple of interesting projects. So there are somebody that are trying to go beyond Hadoop, and I mentioned here a couple of interesting projects. One is in Berkeley, the MP Lab. You're probably familiar with Spark. And they spin off a company called Databricks. Then in UC Irvine, there's a project called AsterixDB from Mike Carey, which is trying to come up with a different architecture. And there's another project called Stratosphere in Europe, where they are trying to develop different systems and do. Whether this is significant industrial is another story, but this is no research. An interesting question that I want to share with you is there is a trend in industry, but also in research, in using SQL also for analytics and integration of data stores. For example, SQL-H is a Teradata query grid. And it doesn't matter, you have SQL, and then you start using SQL also for accessing kind of Hadoop or analytics. Is this good? Now, if you think about it, SQL wasn't really meant to be a language for analytics, but there's a lot of people that know SQL out there. So the problem is, on one hand, you don't want to scare the people, so if you know SQL, you can gently say, I give you an extension to SQL, you can then access analytics. At the same time, if you are familiar with SQL and you know about nested query, some of this nested query you can't even read after a while because it's very complicated. So that's actually an interesting situation that sometimes something that was meant to be used in one way end up being used in another way for reasons that are not necessarily technologically based. And I think there's a trend also in research in using SQL for large volume of data and analytics. And vendors are catching on that. I think it's an interesting question that I can't answer. Well, this is a good idea, but it's happening. So some people use R, for example, in statistics, so now there's an integration of R. Another area that I think it requires attention is graphs are playing a role in big data. You know about Facebook and stuff like that. But maybe something that you don't know is not that familiar. Even Intel is working on graph. Now, one thing, well, Intel Lab, why do they need to create an open source ETL framework, a scalable graph? That's what they do. Well, that's what happened. Intel Lab just open source a scalable graph ETL framework. Interesting, because at the end of the day, you know, when you need to analyze graph, you need a lot of computing power. That's why Intel has all the interest. And graph are a very important data structure. So benchmarking is another interesting area. If you look at most of the vendors, they want to understand how fast is their system. But if you have a system that is not a classical relation database, how can you do a benchmark? Because most of these systems are not, they don't qualify for the classical TPCC benchmark since they don't have the ASCII properties. So how you compare all these systems? There's been some early work in Yahoo. It was the first ever benchmark. They did it. Now it's not really much used. It's used, but not in a way that you think is very successful. But the lesson learned is that everything is very different, and compare different systems is very difficult. That's the lesson learned. So there is a research stream, for example, in doing benchmarking. Hadoop benchmarking, for example, this is one. Just to give an idea, Intel has come up with a benchmark called HiveBench. What is interesting that you don't have any more one workload. You have several workloads for the application you're looking at. You have a machine learning workload, analytical queries, web search, micro benchmark, and you try to measure various implementations of Hadoop. Berkeley has their own benchmark. The TPC, which is the kind of standard body, launched recently in August this year a new benchmark called TPC-HS, which is supposed to be the reply of TPC to the fact that now databases are not only relational. So you need different kinds of benchmarking. I didn't really carefully look at that, but that's an interesting reaction to the fact that the industry has changed. Now, another factor that is connected to analytics is the cloud. So the question is, in traditional enterprise, do they use the cloud? And it seems that we are in a very early adoption for analytics for the cloud. And in general, people, it depends, and we are back again to expectation, are very concerned about protection and security of data. Although, for example, Amazon is doing quite good business with them. So the cloud will eventually play a role, and certain vendors are heavily involved with that, but you need to be concerned about the expectation of people. Here is an interesting report by an analyst done in 2012, a gentleman that was former analyst at Deutsche Bank. Later he joined SAP. But before joining SAP, he wrote this statement, I think quite interesting. He said, okay, not sure whether everybody has a high volume of data. And there he's right, but he's probably missing an important point. It's not really the high volume which counts, it's a variety. So yes, I'm a bank, I might not have petabytes of data, but I might have all kinds of other data that I want to associate it. And he was looking at in-memory databases with great interest. I think it is an interesting technology. And especially the difficulty to find skillful people. Whether this is actually a correct statement, we'll need to double check in a few years. And I like to conclude my talk with, that's the end of the technological overview. As I promised, I was not very technical, but it gives you kind of a spectrum. And I like to, let's say, conclude in the last 5 minutes with a personal touch. So, and I call it big data for the common good. And before coming to this point, I asked myself, and I want to share with you, the following question. Why, in all my careers, I've never been asked what I'm doing, what is the implication? So in our system, for example, as researcher, but even a research in industry, we're not really asked if what we do has a social implication. Normally we go to conferences, we publish, we write journals, or we write software that is being then turned into products. And the question is, I never receive a question like, hey, but what are you doing? What is the implication of what you do in terms of society? And I asked myself, why? And I only came up with 2 reasons. One is a lack of obvious economic and personal incentive. I don't get more money, I don't get promoted, and not even come and say, you're a great guy. So why should I do it? It's not in the system. So, and so I reached kind of a point and I said, why this is happening? Why isn't it possible to involve all this talent in industry, in research, in top universities like this one here, and make an impact? We're doing technology. How can we just try to help? And I stumbled into this quote. I found it quite nice. Big data for the common good. This is also a challenge. It's another kind of challenge. It's not a challenge of the one I list you, the business challenge, the technology challenge. But maybe we could call it the common good challenge for big data. I find it interesting. DataKind is an organization, and I did a little research, and yeah, there are some initiatives, some from the UN, the 3 listed on top. Recently, the Eric and Wendy Schmidt Foundation started something called Data Science for Social Good Fellowship, which is a program at the University of Chicago where they train data scientists for something good. But other than that, there's not much more. And then I was curious, and 2 years ago, I asked a few colleagues in different places, Google Research, IBM Research, a consultant, somebody, Microsoft, well, why? Why that's not happening? And none of the reply that I received were so convincing that you would say, we shouldn't be done. There's an interesting quote of Paul Miller, who was a consultant, and said, well, maybe it's just a matter of priority. And again, it goes back to the incentive. So, and I publish a kind of report where there is some kind of a suggestion how to make the data working for some societal benefit, and there is a report that if you're interested you can download. But I think that the true matter, and I'm concluding with this quote, is really our priority. So we could decide that our system does not have it, so I don't have an incentive, I don't do it. So either we change the system, but the single individual cannot really change the system, or we can share. I want to share with you exactly here that maybe we could look at this as another challenge of big data. I'm only taking big data because that's what I'm doing, but I think you can use it in all kinds of other aspects of life. And maybe that would be interesting to have more big data challenges that are also, as a side product, helping in a different way. Not for everybody. I do not expect that this is a topic for everybody. It's not a must. And I can only share it. I think this is like my very small contribution to the discussion at the moment. And with this, I'm actually finished. Thank you very much. Yes.
So I think that, big data or these technologies around big data, these are simply tools, right? And tools can be used for good or bad. I think we're early in the process, and so today people are using it for economic benefit. But just yesterday on NPR, I heard about this American group starting to look at Twitter social feeds to see, to detect people when they were in trouble, when they were suicidal, to alert people. So I think it's just a matter of time before, the people who are familiar with the technologies start looking at different applications. I think part of the problem is that the people who maybe are thinking about these issues are not the technologists. And the technologists, again, it's a little early in the process for them to be starting to look at the big picture.
But if I can make a comment, I think it's a great point. But what I want to make a comment is, what puzzles me is that these two, exactly, the one developing great ideas and technology and the one that are having a use case or in social, they normally don't even connect.
Yes.
There is nothing in the system that put them, And I think I have a feeling that one person out of 20 might be interested, only that he doesn't know. And exactly, I think there's a need of maybe connecting the two.
Most innovations happen when you go cross-discipline, right?
Yes.
And so
But it's also a challenge because you go outside your comfort zone,
yes.
right? And who wants to go outside your comfort zone? It's difficult. Well, thank you for the question, for the comment. That was good. Yeah.
Question for you. What common good do you think that implies moves toward data privacy or data transparency?
I think what I meant is neither of the two. These are issues, okay? And every, let's say, new technological innovation pose a question like, even when the car was invented, the behavior changed. So in good or bad, you can decide. What I meant is actually, I don't think data privacy is what I meant here. I think what I meant is the intention. How can we foster an intention so that when you are developing maybe solution for big data, you have in mind certain kind of requirements that are not obviously the one listed from the McKinsey report. Nothing wrong with the McKinsey report, don't get me wrong, but it might be interesting to connect it. But this is, I think, is a subject of much larger discussion. So I'm only throwing the question, and of course, data privacy is a major, major issue.
So is transparency.
So is transparency.
Well, the follow-on question is, what do you think of the efforts of the United States government I don't know those are big data problems, but intelligence?
I don't think what I think is actually not really this. I don't think, this is not the area, which I don't want to get into a discussion now because it's not necessarily the common good that I think in terms of positive. This is like a reaction to a certain situation, and then you can start getting into much larger discussion that are not the data. Because this discussion has to do with another dimension that has very little to do with data. It has to do with what you do when something bad happens and how you handle that. I'll just give you an example. I visited Alcatraz. There's a beautiful exhibition in Alcatraz by a Chinese artist. And you go to Alcatraz and you see a place, and this place has a history. And then you can judge by yourself whether you like it or not, but there's a history there. And then an artist that puts some kind of interesting thing. That's another discussion, which I think is much bigger, but it's not necessarily the big data for the common good that I meant. I don't know if I was able to explain you on that point. Yes.
Yeah, ultimately, what is going to be the relationship between commercial surveillance and government surveillance? The commercial surveillance is for commercial property, things like advertising. The more they know, the better they can target.
Yes.
And the government surveillance is the more they know, the better they can target.
But the interesting thing, I want to reverse the question and say, but what about the end user? What about the people in need? What about the guy who has a disease? What about the guy who has no home? That's the focus.
He's in there too.
Yeah, But all
They don't
about
make any exceptions for
sure.
surveillance
But
for
what
those
about
guys.
right? But also, I think it's a matter of focus. It's a matter of focus. So in that respect, this big data for common good would be maybe to start a challenge, and I'm actually sharing here. Maybe write a challenge for the best data scientists in the world, and some are here, that will spend a little bit of their time to maybe think of solution for a problem for that target, which is not necessarily what we discussed. Maybe it could be in healthcare, it could be in area where the food is not there or disease are there and all that kind of stuff. But maybe at the end of the day, it's not going to change much, but it's also an interesting process of self-reflection.
We have this universal problem of obesity. It's an epidemic of enormous
That's not a
proportions.
universal problem, that's really a problem in the United States.
It is not. It is not. It's a problem. It's a problem in Asia and Europe and
Not to
Africa
your area here.
to the same extent. Read your fat chance.
Well, I can tell you a story about it. And in Europe for years, stevia was not allowed. Stevia is this substance that you can use instead of sugar.
It increases hunger.
But it was not allowed for many years, and it was not, it's all about also lobbies and control, and you get into all kinds of different interests. But it's all about intention. That's what I mentioned before.
Allow thalidomide, which we allowed.
But and that's why I was a bit concerned when I read this statement of the European Commission and say, in general, analyzing data will be good. It's all about the intention, and it also depends who decide what to analyze. That's a good point.
And about the side effects.
Oh yeah.
I heard your comment actually about just wanting to keep up from on my first business trips here in 2001 from European Commission members.
Mm-hmm.
And the problem is most people tend to think of it as a binary situation, but when I queried the European Commission members further, they said, no, Europe just wants to keep up with what's happening between the United States and Asia, in particular China, because there was all these kids are growing up. World's largest nation, and that the next great killer app could actually be fully in Mandarin and may not have any direct influence to either the United States or Europe, but could just totally overwhelm the market. What a lot of people don't understand is that when the Japanese, my honorable ancestors, were chewing the lunch of the United States electronics industry back in the 80s, the United States dragged its feet a long time with the high definition television standard. And what most people don't realize is Japanese attempted to brute force the solution with the first HD systems by simply quadrupling the bandwidth. But the United States drug its feet because it wanted to go to digital HD, not merely analog HD. And Japan bet billions of dollars on fabrication lines to build analog high definition systems. And all of those systems, all of that infrastructure went down the tubes. Now, that wasn't bad for everybody. We had locally one colleague who attempted to make use of that fact and build slot machines using those. But his lunch got eaten up by a different industry entirely. But the problem is, what you guys in Europe are hoping to do is at least just keep up with what Asia, principally China, but the other countries will too, and the United States do. And you're trying to, for instance, you're trying to say, we have value in the world because of our content. We have, literature and all kinds of other things, and we're sympathetic to that, even if you don't have the technology.
Well, we do have not that we don't have technology, but I think there's a recognition that there's a trend in the digital economy. You can't stop it, whether you like it or not. So, and then what to do with that? I think it's like an unstoppable movement. And then if this is happening, it's happening anyway. And then the question is how to handle the situation. You can watch, you can be active, but somehow it's happening anyway. So I think they realize that this is actually a transformation. And big data is just a name, it might be much more than that. It is important because it raises expectation. So I like to review with you some of these expectations from a business perspective first, and maybe looking a little bit inside of what the meaning of this expectation. So first of all, what is big data? Big data is around it's always been around, but now what is very interesting is that data is not only the typical structured data that you store in typical relational databases as we know about it, but it comes in different kind of format or no format at all. Like, for example, video, digital pictures, intelligence sensors, GPS signal, and so on. Now, all of this kind of data in volume, but especially in structure, does not really fit into conventional database systems, because they are different kind of things, and there's a lot of them. So, having said that, when we talk about big data, typically, we need to distinguish between three categories: big data, open data, linked data. Now, in general, big data, if you want to have a very rough definition, is anything that doesn't really fit into an existing database because it's too big, it's too fast, or the format is too complicated. And that's actually what I will cover in this talk. There are a couple of others, several countries, there's not only one, and they realize that data is an important asset. And you need the tools, you need the skills, you need the funding. So as an important priority is a statement, and it's an important statement the European Commission has done, quite late if you think about it, but at least, better late than nothing. So, and I'd like to give you an idea of some of the expectation. This is taken from their document. There's a lot of expectation. There's an expectation that the market will grow considerably, much faster than typically, that a lot of new jobs will be created, and that's very interesting, the European Commission is kind of scared that we are lag behind the United States. So what they're trying to do, they're trying to figure it out, niche markets where they think big data might have an impact. And these niche markets are not the usual digital marketing, are not the usual fraud detection, are not the typical suspect use cases, but they're more in vertical, like food security, intelligent transportation, healthcare, energy, and stuff like that. If you think about it, that there is a trend of intelligence sensor, like intelligent meters coming up, this is actually a challenge for everybody. So big, actually, set of data that are typically look at, especially in Europe. One is called open data. That refers to a subset of data that you want to make it freely available for society. For example, for commercial, non-commercial purposes. Public governments are such a case. Now, they have a lot of documents, most of them on paper, and then they digitalize it, and then opening up is a political act. Because that means you have access to information, and then you can build your services on top of that, and is another way of reaching out the citizen. The third one is called linked data, and it's actually linked to the semantic web, which basically means that you would like to link the data together in an intelligent way in order to have a kind of network of data. The interesting thing is the free communities, they develop their own tools, they have their own jargon, but they hardly talk to each other. Interesting. The vendors of big data are not necessarily the vendors of open data and linking data. The scientists are actually working kind of in parallel, but there is a kind of different angle. And to some extent, it's all about data. But, I will focus more on the first, on big data. So, there's a definition that I taken from one of the first reports that was written by McKinsey about big data. A couple of years ago, one of the first, that said big data in everything refers to data sets whose size is beyond the ability of typical database system to actually capture it, store, and handle it. That's kind of neat because in other words, data will grow and technology kind of follow. And if you start talking about petabytes, then you are on the big data side. And anything below that, is large amount of data, but whether it's actually fitting this definition is not the case. I mean, typical relational database system can still handle terabytes, but when you talk about petabytes, then you are really in trouble. So, the European Commission has decided recently, actually in July, that digital economy and big data is an important topic. I think he's reacting somehow to some of the situation in the market, and they issue a strategy where, and it's called the data-driven economy, which is basically a document that they published recently in July 2014 to promote a data-driven economy in Europe. That's an important statement, because then the European Commission is actually driving somehow the politics in Europe, and Europe is actually So thank you for this interesting introduction. As a matter of fact, the level of my presentation won't be very technical on purpose. I will try to give you two perspectives. One is the expectation of big data from the business perspective. And I'd like to share with you some questions that I have on some of these expectations. The second part of my talk is more on what are the research and technological challenges that big data is posing. That could be interesting for students or researchers alike, but also there are a couple of questions I'd like to share with you. And then I will conclude with a personal twist, which is maybe looking at big data in another angle, which is typically not really spoken in normal conferences or at other situations. So the power of word is very important, because with words you are raising expectation. So expectations are important. So if you see here, data is a new gold, or something like that. This is from the European Commission. They are strongly pushing what they call open data, so open the data for services in the public organization and public sector. But you see, the word